We're now going to be multiplying and dividing rational expressions. When we multiply rational expressions, it's just like multiplying fractions using real numbers that you learned earlier. You simply multiply the numerators and multiply the denominators. What we're going to want to do here, though, is factor the expressions in both the numerator and denominator so that we can cancel out like factors. When we divide rational expressions, what we do is we take the reciprocal of the expression in the denominator and then multiply it by the numerator. In this particular example, we're going to be multiplying rational expressions. What we're going to do is take each expression in the numerator, factor it, take each expression in the denominator, factor it, and then cancel out any like factors. So the expression x squared minus 2x plus 1 is going to factor x minus 1 times x minus 1. The expression 4x squared plus 4 is going to factor 4 times x squared plus 1. Now what you should have noticed right here is that I'm writing the entire expression in the numerator over a common division bar. That's because technically all I need to do is multiply the numerators and then multiply the denominators when I evaluate this product. Now, x cubed plus x has a common factor of x. I pull that out, and I'm left with x squared plus 1 in parentheses. X squared plus x minus 2 is going to factor x plus 2 times x minus 1. Now, as I look for common factors between the numerator and denominator, I notice that this x minus 1 can cancel with that x minus 1. And I notice that x squared plus 1 can cancel with the x squared plus 1 in the numerator. There are no other common factors, so in the numerator I'm going to be left with 4 times x minus 1. And in the denominator I'm left with x times x plus 2. Now all I need to do is identify those variables that are not going to be in the domain of the expression. For example, x cannot equal negative 2 because that would cause division by 0. X cannot equal 0 because that would cause division by 0. And in addition, x cannot equal 1 because in the original expression that would have resulted in 0 over 0. So again, it's important to list out the variables that are not going to be in the domain of the result. We're now going to look at a situation where we're adding and subtracting rational expressions, but the denominators are not equal. Here we have x minus 3 over x plus 4 plus x over x minus 2. First thing that we should notice is that both the denominators are prime. So what we're going to do in order to add these expressions is to first rewrite both the expressions so that they have a common denominator. That's easily accomplished because all I need to do in order to get the common denominator in this expression is multiply the numerator and denominator by x minus 2 over x minus 2. In the second expression, I have x over x minus 2. What I need down here is to have an x plus 4. So I'm going to multiply the numerator and denominator by x plus 4 over x plus 4. Again, what you should notice here is that in both these situations, all I'm doing is multiplying the rational expression by what I like to call a well-chosen 1 in order to get a common denominator. So in the numerator, I'm going to multiply these guys out, and the result is going to be x squared, multiplying the first, times negative 2x times negative 3x, or plus negative 3x, gives me negative 5x, and then plus 6. And that's going to be over x plus 4 times x minus 2. You should have noticed that I did not decide to multiply out the denominators. That's because we prefer them to be in factored form. Then plus, here I'm going to distribute my x, and I get x squared plus 4x over, again, x plus 4 times x minus 2. Again, always leave your denominator in factored form. Finally, what we want to do is combine like terms. in the numerator. Because I have common denominators, all I need to do is add the numerator. X squared plus x squared gives me 2x squared. Negative 5x plus 4x gives me negative x, and then I have plus 6. And this is divided by x plus 4 times x minus 2. The remaining step is to identify whether or not the numerator can be factored. After trying to factor this, you'll find out that you'll be completely unsuccessful, meaning that 2x squared minus x plus 6 is prime, so our result is complete.